Okay, so what's the LCM of 6 and 3? You people have forgotten how to find LCM.
6.
So when you're to use the LCM method, the LCM there is 6. But now this friend of mine, she still does her method, you know? She multiplies 3 by 6. And when you multiply 3 by 6, what do you get?
18.
18. So her denominator will be 18. And then she will do what she normally does. 2 times 6, you have 12. Then what is 7 times 3?
21.
21. Thank you. Then when you add these two, what do you get? What is 12 plus 21?
33.
So my friend will end up with 33 out of 18. Now, when you reduce 33 out of 18 further, you'll find that you end up with the same answer as someone who used the LCM method. Because, okay, let's try to reduce it. What number is divisible? What number can we divide both 33 and 18 by? I remember we did divisibility.
3.
3. So what is 33 divided by 3?
11.
11. Then what is 18 divided by 3?
11.
Then what is 18 divided by 3?
6.
6.
So you have 11 out of 6. So have you guys got the idea of this girl's method?
Yes.
Yes. But now,
Yes.
Maria, please mute. Maria, please mute. Thank you. But this girl's method only works for addition and subtraction. Anyway, even the LCM method only works for addition and subtraction, because remember, with multiplication, we just multiply straight, and with division, we do that, that reciprocal thing. So this is what she said she uses for addition and subtraction. I'm going to put a number and you try it out with subtraction, because this was just with addition, or we can first test addition, right? We can first test addition and we see whether we've got her method. But are you convinced by her method, or you need to first try it on all the fractions you know before you believe it? But that's how methods were. That's how people came up with methods those days. You would go, you think, you say, how do I add this one? You try all your ways, you try. Then if it works out, you come and you share with your friends. And you tell them, I did this and it worked out. Okay, so this is an improper fraction, 6 out of 5 plus 3 out of 2. So I want you to add that one up using the other method that I've showed you. And you see whether you will get the same answers if you use the LCM. So like, that is nice. You can use that, especially for big things when you don't want, sometimes the LCM is not very obvious, and it may take you a long time to get it. So you can use this method. So you can work it out, then you tell me your answers. So if you get big figures and you realize you can reduce your fraction, you go ahead and reduce it. And then you give the simplest form as your final answer. Even when you're dealing with the LCM method, you always reduce. Yes, Rihanna?
Sure, I
Pardon, I have not had your answer.
my answer as 2.7.
2.7, and then the fraction
27 out of 10 reduced, I got 2.7.
okay,
Is 209.
because you've got it as 27 out of 10 or 2.7. 2.7 is the decimal fraction. Okay. Anyone else, has someone like got a different answer, or if you have the same, you can tell me, teacher, I have the same answer. Okay, Melissa. Melissa has got the same, but she has given hers as a mixed fraction. So Melissa's answer is 2 whole numbers, 7 out of 10. Okay. Who else? As if I had seen a hand before I went to the board. Okay. Anyway, this was just like one of the ways you can do it. You people can also go back and you brainstorm and see how else can I do this. Okay, so she does the same thing even with addition, just that now with addition, she will be saying minus instead of plus. So with subtraction, I'm not teaching, by the way, I'm just showing you one of my students' ways of doing things. I'm not yet teaching, so you don't need to use your notebooks yet. So let's say, let me use a simple thing. Let me say maybe a third minus a 6. So usually you would get the LCM and O, but she does the same thing. She just multiplies the denominator. So 6 times 3 times 6, what will she get? To be 18. Then she multiplies 1 times 6, you have 6. Now the difference is now instead of plus, this time she will just say minus. 1 times 3 is 3. So she will get 3 out of 18. But 3 out of 18 can be reduced further. What do we divide? Okay, it's obvious that it will be 3. By 3, you have 1. What is 18 divided by 3?
6.
6. So you find that if you use the LCM method and if you use this method, you still get the same thing. Yes, thank you, Melissa. You still get 1 out of 6. But this is not the method she was taught. This is something that she came up with after understanding the LCM method. It's a bit similar. You will realize that for numbers that don't have a very direct LCM, you just multiply. I think that is what they tell you. They tell you that if numbers, for example, 6 and 3 have the LCM is obviously 6, but if you have like 1 out of 5 plus like maybe 1 out of 2, here the LCM is just the product. So she asked herself, what if I just use, the product route? And then she came up with that method and then it worked. And now we believe it. And I know some of you will be using it. That's how mathematicians came up with these things. Sometimes you wonder, where did these things come from? It was people like you that, came up with these formulas and we all adapted them. So yeah, so you can add that to your very many things that you know. I know you know many things in math. Not so?
Yes.
Yes, there are many other things that as we go on today, I'll be showing you, because today I'm mostly going to be telling you how we shall be studying and how I'll be evaluating. So that is one of the ways I'll be asking you to come up with methods. That is a method. I'll also be asking you to come up with formulas. But now someone may ask me, how do you come up with a formula? Of course, I won't tell you, Ashley, tell me the formula of doing this. No, I'll tell you to find something. For example, I'll tell you to, let's see, I'll tell you to, okay, let's see. I can say, find the sum of all even numbers between 1 and 10. So when I ask you to find the sum of all numbers, of all even numbers between 1 and 10, there is no formula for this. People can do it differently, right? How would you answer such a question? First of all, you have to know what even numbers are. Then, of course, people know the numbers between 1 and 10. So how would you answer this question? Yes. Lina, Martha, Florence, how would you guys answer this question?
I would list down all even numbers between 1 and 10, then find their sum.
Okay. Okay, Lina said she would list down all even numbers between 1 and 10, and then she would just add them, because that is what sum means. So, okay, let's list them. So what even numbers do you have between 1 and 10?
2,
2,
2, 4,
uh-huh,
6,
6,
8,
8,
6,
8.
8, 10. Only 10.
Okay, when I say between 1 and 10, it was like without 10. Usually when they want you to include the 10, they will say with 10 inclusive, or they will say between 1 and 11. Okay? Okay, so if this, okay, this is simple, because, there are few between 1 and 10. But now, what if you need to find, the sum of all even numbers between like 1 and like 2021? They say maybe you find, okay, they may not say, because no one is going to ask you to do that, but later on when you're using your math, maybe you're working where? Maybe in URA, or you're working in, I don't know, you people know where you work. I don't know what you want to become, but you may come across a problem that requires you to find the sum of only the even numbers between 1 and like maybe 2021. This is 2021. Then what do you do then? Do you list all the even numbers? Okay, I guess you could do that, but it will be a lot of work. By the time you list all the even numbers, first of all, by the time you reach only 100, then you have to go to 200, 300, then you have to reach 1,000, 1,000, 1,000, 2. By the time you reach 2,000, then you go up to even 2021, it will be a lot of work. So, of course, you'll have to find a simpler way of finding the sum of even numbers. So that's how formulas come about. You think, and then you come up with a formula that might work for you, and then you see if it would work. On most, you can try, after finding out your formula, you can try it with numbers between like 1 and 20, because numbers between 1 and 20 are still many, but you can list them. If you have time, you can list them and then you add them up using a calculator. You see if your formula works. Then you try with like 1 and 100, and you see. After you have proved out your formula, then you can bring it to us, and then we shall discuss it and we see whether we agree or disagree. Okay, now with this one, one of the ways we did it, we used what? Visualization. Do you know what visualization means? Who knows what the word? Okay, visualization is more like imagination. You have to be like really imaginative in order to be creative, and we shall need a lot of creativity in this syllabus. Visualization is when you imagine something that is not there yet, or you imagine an idea, or you get an idea from your head and then you visualize it in form of pictures or in form of a story, something like that. People use it for subjects like what? Like history. When they talk about, I don't know if people still study those things, but I can use primary. When people are studying Mau Mau Rebellion, Maji Rebellion, you can use like visualization. You form your own story in the head, and then it helps you remember when you're in the exam, you're like, oh, yeah. For example, people, have you watched those movies of those South African people? So they always tell you those people of Maji. Was it Maji or Mau Mau? The ones that painted themselves with some magic water. Was it Maji or Mau Mau? Or people have forgotten? It was Maji, yeah? Yes, so like when the teacher is telling you, now these Maji people, they had some witch that they used to trust. Then in your head, you imagine a witch. He's probably wearing back clothes, or he's wearing skin. He lives in like some grass thatched house. That is what we call visualization. Like no one has told you that this witch was even a man, but in your head, the witch is already a man, or the witch is a woman, you know? That is what we call visualization. So it's one of the ways you're going to be using to like come up with these formulas. You can use visualization to, you know, think about things. So like we use visualization for this. You ask yourself, what is 2? Two could be anything. It could be 2 mangoes, it could be 2 hands. So we use just two small dots like this. Are you following? They are just 1, 2. Now from this 1, 2, when people were doing graph work, did you do rows and columns?
Yes. Yes, teacher.
Yes. So you know what a row is and you know what a column is, right?
Yes, teacher.
Yes. For those that are not sure, usually when you sit in a class, the ones that are vertical are the columns, then the ones that are horizontal are the rows. So when you look at these 2 things, we have 1 row and we have 2 columns, because this circle represents its own column, and then this circle also has its own column. As you can see, I'm using a lot of imagination, because now where did the columns even come from? From my imagination. Like there is a column here, there is a column here, but there is only 1 row. So if you have only 1 row and 2 columns, that gives you a shape that is like this. A shape whereby your row is longer than the column. So you'll find that your row is long, but your column is short, which is actually true, because our row has 2 circles, but when you look at it our columns are 2 circles, but when you look at it from the row side, you only see 1 circle, because the other circle will be behind the other. So when you look at it from this side, you will see 1 circle, but when you come here and you look at it, you will see 2. So you will find that this part is longer than when you look at it from this part. And what shape is this? Okay, let me not ask what shape is this. What shape do you think that is? Pardon, Martha, I didn't hear your answer.
I think it's a rectangle.
Okay, she thinks it's a rectangle. Yes, it's a rectangle, because a rectangle is the one that has one side being longer than the other in this form. Of course, a kite can also have one side longer than the other, but the kite is not in this form. So yeah. Then that is for 2. Then we went to 4. I have a feeling someone knows what I'm going to do. So what did we do for 4? Okay, who can try and tell me what you think we should do for 4? Okay, for 4, we just added 4 onto these. So I added here 1, 2, 3, 4. So these are the 4 that I've added, and you realize that still I have a rectangle. So you add on, you just keep adding. So now I'm going to add 6. So I'll add 1, 2, 3, 4, 5, 6. Then for 8, still I add 8 circles. So I'll have 1, 2, 3, 4, 5, 6, 7, 8. Now, when you look at this, now we have 1, 2, 3, 4. We have 4 rows, and then we have 1, 2, 3, 4, 5 columns. We have 5 columns and 4 rows. So here we say the length is 1, 2, 3, 4, 5, 5. And here what's the length of this side?
4.
4. So to get the sum, we just say 5 times 4, which is
20.
20. When you add them up, is that the sum you get?
Yes, teacher. Yes, teacher.
Yes. So like this is one of the ways. So you will find that whenever you're dealing with the even numbers, you're always going to form a rectangle. Then when you try it with odd numbers, you will always form a square. So like that is visualization. So from there, you can like come up with a formula. I've given you like that is like one of the tips you can use to come up with a formula. The other first one is try and error. You try and you see whether it will work. If it works, you buy it. If it doesn't, you leave it. Then this one is visualization. You try to visualize something. And by the way, people have been doing this, especially with word problems. You realize that usually with most topics, after you've covered the calculations part, the last part is always word problems, whereby they will tell you, Mr. Mukasa bought a TV at maybe 1 million, and then he sold it at 500,000. And then they ask you, what loss did Mr. Mukasa, what loss did Mr. Mukasa make? And then you don't even have to calculate it, because in your head, you've already seen 1 million, but then he has sold it at like 500, then obviously he has lost how much? How much did Mr. Mukasa lose?
Teacher, pardon.
Okay, let me write it on the board. Or maybe I use smaller figures. People are not used to dealing with a lot of money, yes? Okay, let's say they say Mr. Mukasa bought a TV set at 1 million shillings. So that is what I had said. Mr. Mukasa bought a TV set at 1 million shillings. He later sold it at 500,000 shillings. And then they ask you, how much did Mr. Mukasa do?
Teacher, he made 500,000 shillings.
He lost 500,000 shillings. But then, like, with such a thing, you may not like really need to like put it in a calculator and like find out what is a 1 million minus 500,000, because 500,000 is obviously a half of 1 million. Like, that is one of the ways visualization works. So even if they ask you what fraction of money did Mr. Mukasa lose, it will be like very easy to see that he lost half of the money. So like, you people have actually been doing this visualization, just that people may not have told you that you're actually visualizing it, but you have been doing this visualization. So it's going to be very, very easy for you to come up with these things. Is it going to be interesting or it's going to be hard? I didn't hear you properly, Martha. Maybe it's the what? The microphone. Okay, I think it will force you guys to like think instead of just cramming formulas. You'll be able to think and you'll be able to even apply that knowledge outside. Okay, let me see how much time we have. I think we'll be able maybe to learn something today. Okay, then even evaluation, we shall be asking things from normal life. We won't be asking you add one plus, you add maybe, we won't be asking you to add things, we won't be asking you to calculate things, we shall be asking you to apply. The way you see those activities of integration, but okay, we won't be asking them that's the exact way they are in the book, but something like that. You people have gotten a chance to look at some of the activities of integration, right?
Yes.
Yes, teacher. Yes, teacher.
For example, should I give you an example of maybe like how we can ask about fraction?
Yes, teacher.
Okay, and we are going to think together here. I'm actually going to use people from this class. Let me choose people. Let me see, I'll use Priscilla, I'll use Megan, then I'll use Ashley. Okay, so let's say, you people have heard of circles or saving groups. I know you people may not do it like at school, but some people do it. Sometimes you can say, let us save together as friends or as dorm mates or as what? Or as just desk mates. You're like, let's save together. Let's save maybe a certain amount every week. You say, let us save, which money is not a lot for you people. Okay, if you guys had to like save together, you want to save, and like at the end of the term, you separate your money. How much do you think you would be able to save without starving?
2,000.
2,000. This is per week.
5,000.
Okay. It's good I've gotten different values. So one person has said 2,000 per week is enough. Then the other person has said 5,000 per week. Now, me, if I was your friend, I would say 10,000. Because now me, okay, let's assume, I'm not saying I'm rich, but let's assume I'm a rich kid. So I can save 10,000 per week. So now we say, now what should we do? Then one of us is like, you know what? We don't have to save the same amount. Let everyone save what they can. So I've already chosen names. I said Ashley. So we say maybe Ashley. Ashley is going to be saving 2,000 per week. Then I've chosen Priscilla. Priscilla will be saving 5,000 per week. Then the other person was who? I've forgotten. Let me put Lina. Then the other person will save 10,000 per month. Now, usually in a term, they are about like 3 months. Let's say they are 3 months in a term. How many weeks are those?
21.
Are they 21? Do we agree that they are 21 weeks? Okay,
Yeah, there are 12.
they are 12.
Yeah.
Remember, every month has 4 weeks.
Four.
So if
Four.
every month has 4 weeks, you just multiply the 4 by the 3, and then
4 times 3.
we have 12. We have 12 weeks. That means each one of them will be saving that amount of money for 12 weeks. But now they tell you somewhere mid-term, maybe like after your mid-term exam, someone comes to you. Let's say maybe a teacher Sheena comes to you, and she's like, you people, I have got a problem. I need to borrow some money from you. This teacher Sheena needs you for what? For saving. So she's like, let me borrow your money, and then I'll pay you at the end of the term with some interest. Then you're like, "Yes, interest, we are going to make more money. So let us give teacher Sheena." So you give teacher Sheena your money. So we are assuming midweek, sorry, midterm. Midterm is like 6 weeks. So after 6 weeks, teacher Sheena comes and borrows the money that you had at those 6 weeks. She comes and borrows the money, all of it, and then she's going to pay at the end of the term. Then you're like, since they've taken the money, we can stop saving there. Let's not save anymore. Or you can decide to save more. You can say, let's keep saving for these remaining 6 weeks. And then when teacher Sheena brings our money, we shall see what to do. Then teacher Sheena brings back the money and brings back twice the amount. They won't even tell you the amount. They won't tell you anything. They will say teacher Sheena brought back twice the amount of money that she was given. So teacher Sheena took the money after 6 weeks of Ashley, Priscilla, and Nina saving. So you have to know how much had they saved in total by the end of 6 weeks. Now after those 6 weeks, teacher Sheena took all the money. So that means that money they had saved is all the money that teacher Sheena took after those 6 weeks. So teacher Sheena brought back that money. It was twice the amount. That means it was double the amount, right? Are you people following?
Yes.
You're following. If you're lost, you tell me. But anyway, this is an example just for you people to see how your questions are going to be looking like. Okay, now they ask you, because remember when she brings back twice the money, that other half, these people didn't put anything, because let's say she borrowed, let's say maybe 200, let's say by the 6 weeks they had gathered 200, it means she has brought back 400. But of that 400, these people only have accountability for the 200. So they have to find a way to divide that extra 200. Are you forgetting? Because that extra 200, yes, because that extra 200 is like a profit. So now they will ask you, how do you suggest that Ashley, Priscilla, and Lina divide that profit? How do you suggest that they divide it? Now, as a mathematician, you're supposed to know. You're supposed to know if each one of them is contributing this amount of money, how much money will they have in total after 6 weeks? Because that's the only way you will know how much money teacher Sheena took. Then, if teacher Sheena brought back twice the amount of money, as a mathematician, you should know what is twice that amount of money. And then you have to suggest, as a mathematician, you suggest as a mathematician. Don't just suggest as a what? As a Christian or as a good Muslim, you see? As a good Muslim, you may say, let's give all the money to Ashley since she's the one who has the least amount of money. Or you say, let's give that money to charity. We don't want those things. You suggest as a mathematician, how are these people going to what? How are they going to share this money? So how would you suggest they share the money, you people? Like, how would you discuss this question? How would you bring it out? You can like raise your hand and you tell me how you think you would answer this question. And we see whether you people are ready. It would be nice if the people involved in this money are the ones who answer. People like Priscilla, people like Ashley. Yes, Priscilla?
Teacher, I think that we could share the money in ratios.
In ratios, where would we get the ratios from?
The would use the ratios of the people who brought the most, the one with the most, who brought the most money gets the most, like that. That's what I was
Okay. Okay. Do you want to add something, or that is it?
That's it.
Okay, thank you, Priscilla. Someone else? You are ready. Someone else? I want someone else to tell me how they would do it. And I want you to use math. I want you to use math. But that is very, very logical. That is like the fair thing to do, because you can't say let's share it equally. Someone will feel cheated. Especially Lina, because now Lina for she has been saving 10,000, and then you want you people to share equally. So it would be fair if you share according to ratios, where the person who contributed a lot gets a lot, the person who contributed moderate gets moderate, the person who contributed little gets little. But now, how do you determine what is a lot, what is little? Will you just get 100 and you give it to Lina because she contributed 10? Like, how will you do it? How will you make sure that, this one has got what she deserved? Like, how will you use mathematics to do that? Yes, I need more people, because still I've not got what I wanted. And by the way, we are not allowed to tell you answers. Yes, Aliyah?
Teacher, I think what we should do is that we should use the fraction things. Like we should add up all the amount together, and we put, like, let's say Ashley, like 2,000 out of the total amount of all of them multiplied by the 200K, by the money that you said, so everybody can get a right amount.
Okay. Then for Priscilla, it will be 5,000 out of the total, and for Lina, it will be 10,000 out of the total. Okay. So Aliyah has used fractions. Aliyah has used fractions to answer the question. So now, me, when I'm marking, I'll be looking for what mathematics is this student using. So Aliyah has used fractions, so I'll be marking fractions. Then someone may use percentages. Okay, percentages is also under fractions, but it's a bit different, because you'll be dealing with out of 100 instead of out of the total. So someone may just get the percentage, you use the total, you get the total, then you get what percentage is 2,000, what percentage is 5,000, and what percentage is 100. Then after getting their respective percentages, then you go and you use that percentage on the profit they've made on maybe they are 200. You said for Ashley, she deserves maybe 2.7%. For Priscilla, she deserves this percentage. Then the first idea was Priscilla's. You can do ratios. You get the ratios from here. If you remember how to get ratios from values, you write them the way they are, you just keep reducing. You have Ashley, Priscilla, and Lina, so I'm going to use A for Ashley, P for Priscilla, and L for Lina. So for Ashley has 2,000, Priscilla has 5,000, Lina has 10. So you keep reducing. So since they all have 3 zeros, you can first lose all the 3 zeros. So you have 2 to 5 to 10. I don't think you can reduce this further. That means that is the ratio, 2 to 5 to 10, and then you use the ratio. So you see, no one has told you to find the ratio. No one has told you find the percentage. No one has told you find the fraction, but you are applying it. So that's how we shall be asking you people. Someone will apply ratios I will mark ratios. Someone will apply percentages, I will mark percentages. Someone will apply fractions, I will mark fractions. Someone may even go ahead and apply proportions, though you haven't studied proportions properly. Maybe if you're using primary knowledge, someone may use proportions, I'll mark proportions. But that is how we shall be asking. We won't be telling you what to do, you'll be telling us what to do. But one thing I can tell you is trust your work and explain it properly. Okay? Is that okay?
Yes,
Yes.
teacher.
Okay, so even during this, okay, mostly during this program, I'm going to be examining like that because when you come back, okay, I hear that when you come back, you're going to do evaluation, that is like exams, those things. So I want you to be ready for that kind of examining by the time you come back here. So I'll be bringing such questions. Even when we cover one topic, I'll be bringing such. Even for topics that you already covered those days, I'll be bringing some questions about such topics so that you know, so that you know, and you're okay. There is a way your brain will be alert if you see many of these questions. Because now I know some of you are wondering, now what am I going to do? But after we have gone through it, you realize it's actually easy. So like the more we look at such questions, you will realize these things are actually very, very easy to apply. And then you people will be able to answer those questions later when they bring them up in your classes and in your groups. This time I've used you people, next time they may use the HM. They said the HM of Navisusa Girls School received school fees from maybe 20 S1s. Okay, 20 are many, they may use 5, they're like 5 S1s. Then they will say Asimwe only brought 60% of the money. This one only brought this. And then they say these students did not report to school, and the headmistress was requested to like give back the money. And then they tell you the policy is that you can't give back all the money, you give back like only this amount of money. Then they ask you what percentage of money is the HM giving back to each of the students. So you have to be able to apply mathematics to find out the answers. Is that okay? Okay, so let me see how much time we have, and then we'll discuss the topics we shall be looking at mostly. Before we went back to school, we had looked at many things. We had looked at sequences, fractions, writing in words, bases. We had looked at construction, but we had not looked at bearing. Marilyn, were you going to say something?
No, it's okay. I accidentally pressed there.
Okay, so okay, if it was like a different class, I would suggest that we first revise everything we've covered and then we move ahead. But then I know the things you've covered have been easy. And then some of you are already repeating the things. First of all, you did them in primary, then you repeated them in high school, then you did them with me, then even when you went back, you did them again. So unless the topics still give you hard time, we shall look at them. But if they don't, we are going to just move ahead. So I think the next topic would be, had you finished construction?
Yes.
Yes.
Yes. Construction, because with construction, mostly you look at constructing the angles, then you look at constructing maybe triangles with the angles that you plant. Then in addition, you can do circumscribing and inscribing. And when I checked the work that you posted, some of the exercises had circumscribing and inscribing, so I'm assuming you covered that. Okay, so the next one would be, okay, the next one would be, let me see. Had you done sequencing?
No.
Okay, so I think we shall
I
start.
don't-
Yes.
Some of you had,
Yes. Some of us did.
some of us,
Yes.
you did and you even finished.
So we're going to the next topic. There.
Yeah. Okay, even me, I wanted us to start from bearing. But then if some people did not cover sequences, then I think we can start there, but I'll find a way to make it more interesting so that people who have already covered it do not get bored. So I'm seeing here, they are normal sequences, but they added something, of course, to make it relatable to real life. So I see there is a table. Okay, there are many tables. You
Yes.
form your own what? You form your own sequences, then you also fill in. Yes, so we shall find a way to go through this one without exactly repeating ourselves. And then we shall also do an activity of integration. Had you done activity of integration for those that had finished? You're not sure? Okay, we shall also do an activity of integration. Then when we are confident with that, we shall move to bearing. It is okay. We have about 3 more weeks, so it is okay. We can, since like sequences are not new, you people have covered sequences in primary, and they're a bit okay. Sequences is the kind of topic that is easy to understand because you don't forge, you don't cram, you use what is there to find the next number. So it will not be hard to go through it. So it's okay. We shall first go through the sequences. Then after we shall go to bearing. And I know even bearing people have covered, but we shall really take our time and we try to, because bearing is like one of the most used parts of mathematics. They use it everywhere. Engineers use it, all kinds of engineers, mechanical, electrical, even computer engineers. Then even pilots use it. Yeah, that's it, right? Yeah, that part of physics. Everyone that needs physics, engineers, pilots, all those people that work that side, they use bearing and angles. So yeah, we shall take our time with it. We shall apply it. We shall apply it as a pilot. We shall apply it as an engineer, and you people see. Instead of just planning to finish, you will see. And if you want to be a pilot, you already know how you're going to use this mathematics. If you want to be an engineer, you already know how you're going to use this. Even models. Okay, so someone is asking, are we going to be writing in our workbook? Even Daniela had answered me the other time, 500,000. Yeah, okay, that's good. Are we going to be using writing in our class books? Well, I think you should write like in a notebook, because even when you go back to school, you're going to repeat. Because I don't know if you're all from Navisunsa, but those from Navisunsa, there is no online program. That means when you guys come back, you're going to start from where you stopped. So it will be repetition. If you write in your workbooks, and then even when you come back, you write again in your workbooks, it will be repetition. So I suggest you get like a side book and you write there. You can get like one book and then you write everything in there. Because mostly I'll be looking at exercises. Then once in a while, I'll ask people to show me your work. So like you just need somewhere to note down so that you're not just watching as if you're watching soccer. What about students who are sick and cannot be able to do the classes? Okay. The people who are sick. Okay, I know that people are sick, but is there anyone that is really like too sick to attend an online class? Are there people like on oxygen? I don't know. I know that some people tested positive, and I've tried to check on some of them. They are on medication, but they are fine. They are fine, like they can walk, they can talk. They are normal people, just that they have the virus. So I think such a person can attend class, but those who cannot, when they join us later, we shall do a little review. The people who have been studying with me know how we've been doing it. Usually when we finish, when like towards the end of the program, we review everything. Some are on oxygen and they can't even attend. Hey, you people are what? You're getting me worried. Some people are sick like that. Eh?
Yes.
Oh, that is so sad. That is so sad. But when those people come, whenever new people join, I always find a way to cater for them. Maybe if you're talking about other subjects, I'll talk to Mr. Namdala and Mr. Baiman, and we shall see how to cater for those people. Eh? Don't worry about them. When they get fine and they join us later, then we shall see how to help them. Elizabeth had her hand up. Yes, Elizabeth. Okay, maybe it was a mistake. Okay, I think that is it for the questions. Okay, so I was still telling you, that is one of the ways I'll be evaluating. The other way, I might look at your work in class, like right away. Sometimes I'll ask you to put on your video and show me your work. So please make sure that whenever we are doing hands-on work, you do it. Later on, when we start bearing, we shall be doing hands-on. Like you can't just study bearing by just watching the teacher. You have to like work out in your book. So sometimes I'll just be asking you people to show me your work after. So always make sure you're working out. Then another way is handing in. I hope you already know how to hand in. Sometimes I'll give an exercise and ask you to hand in your work, and then I'll mark it and send it back. If you haven't yet learned how to hand in your work, please use this remaining free time. I think you have free time after lunch. You can use that one to like consult. You can consult me, you can consult Mr. Namdala, you can consult your friends, and then they will tell you how you can like hand in the work. Yeah. Yes, Regina.
I'm asking, where are we handing in the work?
On the e-learning platform.
Okay.
I hope everyone is already there. That's where we shall be handing in the work. Okay, are there any more questions? No. Okay, let me write my number in case someone has asked. I think it's Zoe. So that one is mine. Then the one for Mr. Namdala. Mr. Namdala is always talking in class, in the group. So you can, it's very easy to get that one. Then the one for Mr. Baiman is the one you usually pay to. But for anything, you can always ask me. Even if I can't answer it, I can ask Mr. Namdala for you. So that is the one on WhatsApp. Yes, you're welcome. So on WhatsApp, you can DM me. Even for now, especially for chemistry, chemistry, I'll be asking you to send things like videos straight to my number, like videos of experiments you'll be carrying out at home. You'll be sending it straight to the WhatsApp. So you can write it somewhere, even if you don't have a phone. There are ways of sending those videos. How do we hand in? Have they sent those videos yet? Let me see. Okay, Pamela, are you on WhatsApp? I don't know if Pamela is on WhatsApp, but if Pamela, if you're on WhatsApp.
Yes, teacher.
Okay, there is a video that they sent before they sent the timetables of how you can hand in on the e-learning platform. Maybe what I can add on is please make sure you always hand in your work in PDF form. You scan and you save it as a PDF folder. You can just start naming them. The first exercise I give you, say math assignment 1, math assignment 2, math assignment 3, like that. Then for chemistry assignment 1, chemistry assignment 2, like that. Then you hand it in as a PDF to the platform. I also haven't watched the video yet.
Okay.
But I think it's there. We shall keep learning. We'll learn these things. You learn them, and with time they'll become easy. Okay? Have you written down the number?
Yes.
Okay, any more questions? Ryan, I've not had you ask.
There's some, excuse me, teacher.
Yes.
There is something I never understood. I went off because of bad network.
What was it about?
Are we going to still be handing in using the Google Classroom?
No, we are going to use the e-learning platform. We want you people to learn, because even in the future, we don't know what is going to happen. We don't know if this virus will go away. We don't know if, we really don't know. We don't even know whether even after the 42 days we shall come back. We don't know. So obviously we need to like practice with that platform, so that even in the future when the whole school decides to have like online classes, you people have already learned how to use it properly. Because yes, once most of you were disturbed during that short period you were at home when you were doing online classes, some of you didn't even attend any of the classes because of the difficulty in what? In using ICT and all. So we want to, as we are, as much as this is a private program, we want to also take advantage and help you people get used. You get used with the e-learning platform, so that in the future, if you like, you need to use it, at least you're good. So we shall be using the e-learning platform to hand in the work, not Google Classroom. Ryan, have you got it? Did she go off again?
Yes, teacher.
Okay. Any other question? Okay, that's fine. Hey, I also had other tricks to show you, like ways you can do something. Maybe I can show you one. There is also another one that we discussed with her. We have only 5 minutes remaining, but it's not hard. I can just show you, and then you will try it out in your free time, okay? And by the way, okay. So we shall end here for now. I'll show you that trick next time. Is that okay?
Yes, teacher. Yes.
Okay. Bye.
Thank you, teacher, for teaching.
Ale, thank you too.
Thank you, teacher. Bye, teacher.
Bye. You're welcome, Asimwe.